much for sticking around for the last presentation. I know it's hard after a long, long day. I appreciate the temptation to not go grab a beer or anything like that, okay? So I hope this will be something useful for you guys. I hope it will be something that maybe will teach you something, okay? I'm going to be talking to you about developer productivity engineering at CERN from my perspective, right? Because CERN is a huge organization, so maybe in other places, other things are happening, okay? Just to start, I'm going to introduce myself. My name is Cristian Schuszter. I am a fake German. I'm not a German person. The surname is misleading. I'm sorry for that. If you talk to me, talk in English, please. So I work at CERN. I work as a solution architect in a team of very talented software engineers. I've been around for around 7 years or so. And let's say I have around 11 years of experience in the field. I used to work in computer security with the SSO team, and now I'm working in something called the business computing group at CERN. I'm also a CERN guide, so I don't work in construction, as the photos might tell you. I actually guide people underground in safety first, so if you're ever in Geneva, feel free to hit me up. I can maybe arrange something for you guys. I also have some academic experience as well, so I did a PhD in systems engineering, and I focused a bit on deep learning, fault prediction, and so on. Now, we're not here to talk about myself, we're here to talk about these topics, right? So we're going to have a light intro. I invite you to scan the Slido thing and ask me questions during the presentation as you see the slides, rather than actually waiting until the end. So, we're going to be talking about the intro part of what we do and the challenges that we face in the environment that we have at CERN. Then we're going to look at the homogeneity in our environment, or what we try to put in place in order to make it as homogeneous as possible. And then I'll be talking a bit more on the, let's say, Java tech side, right? So I'll talk about Gradle and the related tools that we use in order to make our lives easier. And finally, maybe draw some conclusions based on what we've seen, okay? Now, this is CERN. Well, it's not CERN. Actually, this is an aerial view of the French countryside with the 4 accelerator points, right? The 4 experiments, LHCb, Atlas, Alice, CMS, and so on. It's a 27-kilometer tunnel. It's one of the biggest, it's the biggest instrument that we've ever built as humans, right? And of course, as you can imagine, there's a lot of work related to it, right? And, you know, they look a bit like these, the machines, of course. We're not going to be talking about the machines themselves because most of the code that's running there is very low level. It's not Java. I'm sad to tell you that, but it's not Java, right? But we use a lot of Java in many, many things. Also not this. This is just to show you that you know, you have some cool explosions in the middle of the accelerators and so on. For example, whenever you come and visit CERN, you get like a nice schedule of what's on during that day, right? Everything which is related to visits management at CERN is built in our business computing group, which is kind of like, let's call it a consulting company for all the other departments inside CERN that want to build something related to the admin sector, et cetera, right? So, as you can expect, there's lots and lots and lots and lots of things that were written over the years. The organization exists since 1957, okay? And because of that, we are pretty complex. We also have a lot of complex systems. This comes from stakeholders that wanted to build things from us. That's a high-level diagram of the financial systems only that we manage at CERN and so on. All the inputs, outputs mean different things. I didn't zoom in because it doesn't make sense to spend our time here understanding what happens, right? I'm just trying to convey the message that it's hard, right? Life is hard because things are complex, right? You might have experienced this in your fields of work, your companies, and so on. It's no different where we are, right? We also have a mix of legacy and new projects. We develop new things all the time, but we also have a bunch of legacy just lying there waiting to creep out and strangle you, right? And we cannot afford to reinvent the wheel every time. Every time some new technology comes out, let's jump on the hype train and start using it. Let's put LLMs in everything. Well, if you put LLMs in accounting software, I think creative accounting will not be appreciated by the member states, right? When you start like hallucinating about numbers and so on, right? And we're also quite a few people in the group. We're around 80 developers. We have POs, PMs, designers, which I didn't include in those 80 people, right? So we're quite a big machine. And I included a couple of screenshots here just so you see how the systems might look like over the years, right? So it's not exactly the same screen because I couldn't find it, but that thing that you see on the left side there is like a text interface for one of our ERP systems. A screenshot taken in, so that's a document from 2000, but in principle, you could have seen the same documents in 1991 in production, right? Fast forward to the present day, we have a nice interface, but everything else behind the scenes essentially is the same, right? Processes evolve, they change, you add new things, you remove some of the old processes and so on, but they're still there, right? How many of you are working on 30-year-old code bases? Okay, those people in the middle are my colleagues, so don't trust what they say. If you want to ask them about things, you can do that after the presentation, okay? Now, another very interesting thing is actually something that was presented at Java 1 2000. How many of you were at Java 1 2000? Yeah, exactly. So neither was I because I was busy going to first grade or something. So anyway, Derek, one of our colleagues in the group, he presented this new fancy application that at the time was really revolutionary because in '98, when they put it in production, it was written in Java. Huh? So that thing on the left side, the material request, is when you want to buy something. You want to buy a new MacBook at CERN, you go, you fill in that document, it goes through an approval workflow, and then you get your MacBook eventually, right? And on the right side, it's the same thing. It's just the one that we see today. Of course, the interface is not maybe the most beautiful thing because it doesn't need to be. It's functional, right? And what I'm trying to say here is that we went from this application built with Java Servlet API, Oracle 8i, Enterprise Java Beans architecture, and workflow. So there was a thing called Oracle Workflow. You know, now we use Camunda for the workflow, but it's basically more or less the same thing. We still need to maintain this, right? You can find code that was in CVS or God knows where, you know, with commit headers from 97 or whatever, right? It's an interesting challenge to actually keep everything up to date, right? And we also need to, you know, update our infrastructure, go to Kubernetes, deploy stuff, and so on. So let's see what we do about that. So the conclusion, at least from our side, is if it's still used inside CERN, it's not legacy, right? We keep rolling it as long as possible. We can't afford buying new stuff all the time because we're busy with the physics that I just showed in the first slides, right? Now, it's expensive to be inefficient, though. Even if we have legacy systems, when things break, it costs a lot of money. So the shutdown of the accelerator costs around something like 100 million francs when it shuts down for like a year or something, because that's the estimated time that we spend upgrading stuff and not doing physics inside it, right? So it costs a lot of money. And of course, you might say, yeah, sure, but you guys are doing the admin software. Yes, but if that doesn't work, then suppliers don't send you parts in time that you can install into the machine. You can't pay invoices, et cetera, right? So that's quite a bad situation to be in. Another horrible issue that we face is turnover. The average tenure of a person is around 2-3 years because we have short-term contracts. The graph here shows staff contracts, which are a bit longer, like 5 years, 8 years, it depends on the person. But you can see that there's slightly more people arriving than departing, but it depends on which category you look like. But the highest turnover, of course, is in the scientific and engineering work. This is the CERN personnel statistics, so you can see it publicly online if you Google for it. That's bad, right? How many of you have huge turnover in your company? All right, some of you, let's say 10% maybe, okay. And of course, being so many people in the group, we end up in the situation where we have cognitive overload, as I would like to call it. So when you join, it's overwhelming. Why? Because there are so many things going on, and there are so many domains that you aren't even aware of. You don't even know what's broken because you don't have a full overview of everything, right? And this is kind of a diagram of all the, let's say, all the domains that each team is responsible for. The red bubbles there are actually teams, and you know, it can lead to siloing, which is also a big issue, right? So you have people which know something or do something really, really well in a team, but they don't necessarily maybe share that much with other members of the group, right? So innovation kind of stays in one place maybe, and it doesn't go around a lot. Not great. Okay, so given all that list of huge problems that I've just shown you, let's see what we can do about it, right? So let's see how we actually tackled a bit some of these things with the work that we do in the group. So the first one is kind of a low-hanging fruit, you know? So how many of you have used this Yeoman project in your lives? Yeah, so it's kind of nice. I mean, maybe it's not really fashionable anymore, but you can actually do some really cool stuff. You can take the Spring Starter project and then say, okay, do you want a Spring application? Yes. Do you want to connect to the DB? Yes. Do you want to connect to the DB and use God knows what? Yeah. Do I want a CI/CD pipeline? Yeah. Okay, so the nice part is that it's quite easy to implement. So you just go there and you say, okay, if the flag app vault integration is enabled, I want to use Spring Cloud Vault, right? And with Spring Cloud Vault, it's super easy to just pull in secrets from a random undisclosed place, right? And be happy about it. You don't need to save passwords in your local environment. Or if you change the passwords, then you're really not happy with the situation, right? Then, in terms of the silos, this may or may not be a real presentation that we had from an undisclosed company about how they built testing systems for the military and all that. They said, oh, this is very similar to what you guys do at CERN, right? We were like, no, not really. But well, we had an interesting presentation, and this is in one of our communities of practice, right? So the thing is that we have this idea that even if you're working on your day-to-day work, we allocate around 20% of your time so you can learn new things, improve yourself, and so on. And if you want to collaborate with your colleagues or share something to the rest of the group that you've done in the team or that you find interesting in the work that you've done, you can do a presentation at the community of practice. We have one for backend Java, UI, DevOps, reporting, and so on and so forth, right? So that's kind of a nice way to share the knowledge between people. Another interesting thing, we used to include YAML files. We use GitLab as our main CI/CD solution. And I don't know how much you know about it, but in GitLab now you have something called GitLab Components. It's kind of a new thing, which allows you to do the same thing as you did before by importing a YAML file and saying, look, I'm going to need to run SonarQube, for example, on my project. But you can use a certain version. So basically, when you tag that repo, you can actually say, OK, I want to use this component, which is implemented in a certain way. And it also generates you some documentation nicely here saying, OK, these are the parameters that you can pass to the GitLab CI components. So that's awesome, because our DevOps team is basically preparing this for us, and everybody across the group can share them, right? So it's not a bad thing. We also were kind of getting there with the GitOps solutions. So we use Argo CDs. Have you heard about Argo CDs? Yeah? Yeah? OK, cool. Are you using Argo CD in production? Yeah, less people than than before. Yeah, we're using Argo CD in production, and it's quite nice. Well, I took a photo of the dev environment. Shame on me, right? I didn't show you the prod one. But it's the same thing. So the idea is that with Argo CD, we just, whenever we push, it's going to eventually redeploy. We have a nice rolling deployment. Everybody's happy, right? And we have plenty of services which are running like this. We're happy with it. It's making life way easier than having to manually deploy things. This is pretty obvious, right? But just putting it out there because maybe you're interested in trying it out. And of course, once it's there, you need to do something with it, right? We use OpenSearch, so whenever we want to do some logging, tracing, and so on, we log using the Spring Boot ECS format. So since Spring Boot 3.4, I don't know if it's 3.4 or 3.3 or something like that, you can specify, OK, logging ECS format just very easily in the config, and then it suddenly spits out these nice things here that get indexed by OpenSearch, and then you can, well, search, right, as you would expect. It's really good. It's really practical. So now most of our applications, all of our applications almost, they use the nice ECS format here. For more, let's say, observability-related things, we use Sentry. How many of you are using Sentry? OK, 3 people in the room. Are you doing observability in your projects? OK, so 20% of the room, fine. So I suggest you look into that because it's really, really, really useful to get a nice alert saying, this database query is super slow because we analyzed, I don't know, 10,000 calls that we got, and out of those 10,000 calls, 5,000 were more than 500 milliseconds or whatever. Of course, you could do this yourself, right? But why would you go through the pain and suffering of implementing everything when you have, well, you have open source solutions, you can use OpenTelemetry and so on, or you can go ahead and use Sentry to give you all this information out of the box. Of course, you might need to pay a fee for that. I don't have any I'm impartial to whether you buy the thing or you use open source. If you can use open source, use it. But in some cases, sure, we pay for some of the tools that we're using. Now, getting a bit more away from this into a more architectural, let's say, area. This is one of our ADRs. So ADRs means architectural decision record. Are you using ADRs? Yeah, cool. So that's nice because basically it allows you to understand why a certain thing was done like that in a project as a high-level thing, right? So you have pros and cons and so on and so forth. So we definitely are happy using this. We also have kind of like an ADR repository grouped by domain and so on. It's really cool. It's really useful. We get people from the architecture team to review other people's ADRs and so on. It makes a lot of sense, and you have a central repository of decisions, which you don't have a ton of documentation. You just have one document which basically says something very useful about one point in time of our application, right? And something very nice for you PMs out there or whatever, we track technical debt, and we tackle things as features, actually. So every quarter or so, we kind of say, hey, what do you guys want to work on? Well, this, because it's really bad and it's making my life hard, and it's really hard to develop a new feature for this application, right? So actively, we invest time into this, and we pay, let's say, a cost to actually get the technical debt features out there and solved. So we do some t-shirt sizing based on different things, and there's some sort of score which computes how much of a certain application is painful, right? And that's the thing that we tackle first, because of course, 30 years of legacy, you know, so you need to start somewhere. And finishing up with the architecture stuff of things, we actually use hexagonal architecture in some of our applications, or a variant of it, let's say. And we're quite happy with ArchUnit. You saw maybe there was a talk about ArchUnit and so on. I encourage you to use it. It's quite nice because at least it makes sure that you're not doing really dumb stuff in terms of things getting super tightly coupled in your projects and so on. Of course, if you have a small project, maybe you want to just ditch the whole thing and start easy, but once you get past the POC, the POC implementation, you actually want to be in a happy place where you can change things rapidly, right? Now, when we want to adopt new tech, like somebody says, hey, I want to start using Rust in our stuff because everybody says Rust is super cool. Well, the initial response is no, right? Most people are happy with the homogeneity in the group, also because you can jump from team to team. You go to a completely separate team in the group. Of course, the code might look different because it's written by different people and so on, but you get the point. You know that it's using more or less the same tech stack. It's all Spring Boot. It's all yada yada, right? So whenever we go through this process, we actually have a, let's say, internal discussion saying, look, for example, create React app is dead. This is a front-end example, but okay, you can use your imagination. These are the pros and cons of using different other libraries instead of actually relying on this thing, because it's dead and it's unmaintained. It will make our life hard in the future. So we go through it. We do some sort of, let's say, light review process and so on. And then if everybody's happy, we do a Roman gladiator move, and we go with yay or nay, okay? And once that happens, we actually start planning it as some sort of features in the roadmap in the future, okay? We also use this. It's not particularly up to date, but this is a tech radar. You know about tech radars? Yeah. So this is our tech radar, or at least it's more or less what our tech radar looks like. Maybe we adopted a couple of things in the meantime and we didn't update it, but it's split by quadrants, right? So we have a backend one, a front-end one, a commercial tools one, because sometimes it's easier to just buy stuff rather than implementing it yourself. And for and we have an infrastructure one, which is basically all the things that make our applications run nicely, right? So I would encourage everybody to have in their organization some sort of tech radar. It's quite a low barrier of entry for that. At least you have a nice visual way of knowing if something is maybe out of reach because of some idea. And then you go back to the ADR, which decided why we shouldn't be using this kind of stuff, right? So everything goes together in a nice little image that helps keep sanity, right? You go from a very chaotic point of view to a bit more organized situation. That doesn't mean you're forbidden to use a certain technology or that we beat you up if you start using Rust in your thing. It needs to make sense. That's the only thing. All right. Now, we are getting a bit into more Java developer land topics, right? So we're going to be talking about Gradle. How many of you use Gradle? Okay, so okay. So yeah, how many how many people like Gradle? Okay, it's more or less a similar landscape. Yeah. So Gradle has some, the community has some beef with Gradle and so on. I'm going to tell you why we use Gradle, but also I'm going to tell you why, why maybe you wouldn't want to use Gradle, right? So one of the reasons is actually historical. So some people really liked Groovy back in the day in the group. So yeah, we ended up in the situation where everything was groovy. Well, not everything, but many things were groovy. And Groovy, as you might know, is a great language that wasn't fully implemented, right? So because of that, you don't want to be in the situation where all your code base is in Groovy, especially in 2025. It's not in Groovy, don't worry about it, right? There are some nice plugins and so on, so you can use them. We use it for everything, from DB migrations, deployments. Even people that don't do Java in the group use Gradle as the backbone for their DB migrations and so on, because we just agreed everybody uses Liquid-based, so we're happy with that. But as a con, maybe you know the API is not the most stable API that you've ever seen in your lives, right? So if you've used Gradle in the past 10 years, you might have seen 10 different ways of doing things in Gradle. This is why people don't use Gradle and don't like it that much, right? I'm not paid by Gradle, so I can say that nicely. Now, in the olden days, back before I actually even joined the group, people implemented something called the AIS framework. AIS is the previous name for business computing because we really like acronyms at CERN. It was the Administrative Information Systems group. And the idea was that, okay, why don't we build plugins to do everything in Gradle, right? So let's just go ahead and implement stuff that allows us really quickly to connect to our Nexus instance, right? Like, for example, you just pass in this nice little AIS Nexus public thing. You have something in your init Gradle. I won't show you because I actually have some passwords hard-coded maybe somewhere around there, so no. And then magically it knows how to connect to our Nexus instance at CERN, right? So that's great because it improves developer life a lot, right? However, the problem is that the APIs break all the time, right? So by the time we moved from Gradle 3 to God knows what, to 6 or whatever, nothing was working anymore. So then you either spend a lot of time actually fixing everything, going through super cryptic errors that you have no idea how to fix, or you just abandoned it. And we ended up in the situation where we just said, actually, the whole thing, we also had the GWT plugin and so on. There are some super old presentations about that. I will spare you the trauma, okay? But the idea is, maybe don't implement plugins for Gradle for everything that you do, okay? I copied the wrong slide. You haven't seen that, never mind. Now, let's look at some new features in Gradle and maybe why you would want to invest some time learning it or using it, right? One of them is build caching. Do you use build caching? Yeah. But maybe you use it with something else as well, because you have NX nowadays, you have Maven. You can actually implement build caches in Maven. There's a plugin for that and so on. I wouldn't know because I'm not a Maven user, unfortunately. But the idea is that people think, oh, all this cool stuff, it's actually paid. Well, it's not. So if you go to Docker Hub and you search for Gradle build cache node, it's free and easy to use by everybody. You can just like spin up an instance of it. And then you get this UI looking thing here, which says, okay, build cache contains I don't know how many entries. This is the thing that we use in BC. And there's a low barrier to entry, right? So in your settings Groovy, you just specify a build cache block, settings.gradle.kts actually, because you're using the Kotlin DSL, I hope. And then, of course, you say, look, I want a remote build cache, I want a local one, and so on. So you implement all this stuff, and maybe you pass in some credentials because it's protected so people don't push malicious code into your build caches and infect your system, right? And it's great, like Gradle really likes to brag about how fast things are now that you're using the build cache, but it's true, like we're really happy with it. So if you look there at the top, it says 75 tasks executed in 14 projects, in 45 seconds, with 19 avoided tasks, which saved us yet another 11 seconds. Can you imagine what you can do with 11 seconds every time your build runs? Well, if you have a big project, maybe it compounds into something, right? So it's pretty useful. And I encourage it pretty much. Now, another thing that's quite useful, and we started using it a bit to create some sort of monorepo-ish looking thing, is, well, the Kotlin DSL, but then there's something called version catalogs. Have you heard about the version catalogs in Gradle? Okay, like 2 people. Yeah, it's a pretty new thing, which is quite nice. You use TOML, this yet another language that you need to learn, to define your dependencies. And you say, look, this is a liquid-based example. So you say, look, I have liquid-based with this version. I'm using that version to pull in this module. It's in a bundle with all these other libraries. And in my build Gradle, I actually have a strongly typed dependency management system, which means if you type libs.something, you're going to see in a second in the demo, it actually knows where to pull things from your dependencies. So you don't end up in this weird situation where you type something and then it makes no sense anymore. It's nice for individual versions, but it's also super cool for the bundles because then it expands, right? So you say, look, I have the liquid-based bundle and I need all these dependencies in order to make liquid-based work in my project. So you just say libs, bundles, liquid-based, and boom. All of those 3 things are actually included as dependencies in your project. You can do more wacky stuff with platforms and so on, of course, but this is enough for us, and we actually use it to run all the, let's say, all the scheduled jobs that are doing some sort of logic. They're actually built in, they're built in Java and they're deployed in one single image, and each of them is using this version catalog, allowing you to have the same dependencies across all your projects, which is great. You need to upgrade Spring Boot versions? Sure, you just increment a number there, and you end up in the situation where everything just works, right? Without you having to go chasing through I don't know how many projects. Maybe an honorable word of mention, we use SonarQube for our code coverage and so on. It's quite easy. With Gradle, it's quite nice because then you can just use the Sonar plugin and so on. And it integrates nicely with GitLab too. So whenever you open a merge request, you get a nice dependency report and so on. How much you covered of your code. We have 80% minimum coverage for everything, front end, back end, whatever you want. And yeah, it's useful. And it works very easily and nicely in Gradle. Now, to find out where stuff is, because not everything is a monorepo, we use something called source graph. Heard about source graph? Yeah, so source graph is amazing because I can even show you for a second the moment we do the demo. But source graph is really cool because it allows you to search in anything, and when I say anything, you can search in a certain commit in a certain project for what things changed, which is really powerful compared to the normal, let's say, vanilla search that you might find in GitLab. You can use the one which is backed up by Elasticsearch and so on, but it's not as fast and as good. You also get the nice feature like in GitHub where you can navigate between projects and between things that reference each other. It's quite useful. There's also an open source alternative. It's called SourceBot, but it's a bit less feature full, right? So you're paying for SourceGraph because it does the things that the other free things don't do. For secrets, we use Vault. So whenever you need something, we use the Spring Cloud stuff, and then it's like, for example, here we load stuff from app travel sync dev, because this is the dev configuration, and I say put everything in travel sync secrets dot. And then whatever is in that collection of keys there actually goes into my my environment. They're passed into all my Spring Boot configuration, and then I can use it, for example, to pass in the password for my data source, which is also nice because it's all the things are in one place. If I need to change a password, then there's one source of truth. I don't need to go chasing around things in my CI configs and so on. It also gets packaged into your application, so as long as you can still contact Vault, you can configure your application at runtime. So if you change anything, you just restart the pod or whatever, and it will suck up the new secrets, which is quite nice and useful for our use cases. Now, let's look a bit at Gradle build caches and so on, maybe touch a bit of code. You guys have time to ask some questions, and then we can do some wrap up. Now, I have two machines here, mine, like the one where I'm presenting from right now, and I have my my little machine running at CERN somewhere. And I'm going to bet my money on the fact that the build cache does its job properly, right? Now, I have a little project here. It's going to be linked somewhere at the end of the presentation and so on, using the latest and greatest. We're using Java 24 and so on, and Gradle 8.14 because 8.13 doesn't support Java 24. So just telling you that. Now, we have a couple of, maybe I can show you the README. Where is it? Oh no, it's not rendering. Never mind, what's going on? Wait. IntelliJ decided to take a break. What are you doing, IntelliJ? Well, that was okay. Well, while I put a pillow over IntelliJ's face, there we go. Did it die? It died. Okay, so let me just restart this. Meanwhile, we can read the README from GitLab. So this is a GitLab project that's actually public, so you guys can access it. So we're going to talk to the BC Gradle cache, which is deployed here. It's sorry, I don't have the nice little things here. Yeah, which is deployed here, right? So don't try accessing it. It's behind the firewall, and also even if you try to access it, it's password protected. So good luck. Now, for the demo, we're actually going to be pretending that we do some tasks because we don't actually want to write any code necessarily. We just want to simulate, for example, a CPU-intensive process, which is this one, process cacheable resources it's called. And then there's another task called generate code, which generates some Java output in a build folder. And if everything works properly, the moment I run my project again, of course, it will work out of the box, right? And then we have a stupid task which basically just does the two things together, right? Is it back to life? Let's see. Build cache. Yes. I'm not going to open the README again, so I'm just going to show you the README from here. Now, in my settings Gradle, I have the build cache configured and so on and so forth. I use the local one and the actual remote build cache. So by default, it uses the local one, and then if it doesn't find anything there, it uses the remote thing. And in here, if I look at my tasks, I have Process cacheable resources, which is cheating, right? It just does a thread sleep and it waits 5 seconds, and then after it's done sleeping, it says resources processed. Okay, so I can simulate that something that takes a long time happens, right? So I can do process cacheable resources. Did I? Wait, let's just clean everything. And compiling the settings file. Well, this is the price that you pay for having strongly typed configuration. You need to compile your config files, but okay. So let me just delete everything related to caches. So like my home directory build cache, I'm also going to delete the build cache folder, which is in the project here, and I'm gonna do a Gradle clean, okay? So nothing here. There's nothing in the build cache. So now if I do a nice little Gradle process cacheable resources, execute 5, boom, 6 seconds, right? So of course, because it slept a bit, and if you look into the build cache folder here, you can see that there's a new thing going on. There's another file there. It's binary. Don't try to open it. But the idea is that this is where my build cache for the project is going to be stored, right? If I do process cacheable resources again, what will happen? Nothing, right? It's already done. It knows that I didn't change anything and so on. Now, if I change to 6 seconds the sleep time, what will happen? It will run the task again because there's no cache for the 6 seconds. Actually, what the cache does, it stores a hash of my current the current thing that I run, and it puts it in the folder there, right? So boom. Now I have multiple cache files and so on. Now, if I want to run the whole thing, I can just run the demonstrate caching task. Clean. Let's go clean. Demonstrate caching. Yeah, we can run it with a scan. So this is going to generate. Yes, take my data, Gradle. Okay, so here you have a bunch of stuff. This is a build scan of what I just built locally. If you look at the timeline, some stuff happened, okay? And then there's the process cacheable resources. If you look here, it says build cache result, miss, local and remote, store, local and remote. Which means I stored something in the remote instance of my Gradle build cache node, but also locally on my machine. So ideally, if I run this again, well, it ran way faster than before, right? Because nothing really changed. There's a way that it computes the dependency graph. So it ran again the process cacheable resources task, but you can see that this one, okay, up to date, up to date, up to date. Yes, but then I can also run it with rerun tasks. So up to date means, okay, I know there's nothing there because I've already ran it and I know about it. But I actually want to rerun everything. This is it's not the best example because the thread sleep will still run, but everything. Did I disable the cache? Wait a second. Maybe I disabled it somewhere. Anyway, so yeah. When it works, it's fine. It's way faster than you would expect. Now let's look at the real project, okay? So let's look at this nice little monorepo-ish project where we store different cron jobs. Let's say it may be in a different language and so on. We have a folder called dependency catalogs where we put all our dependency, as you might expect. So all the Spring stuff and so on. We generate invoices, we do a bunch of stuff, and we use them either directly or as bundles. So for example, liquid-based, like I was showing, this is a real example. Or Quarkus, we have all these things that go into Quarkus. We have Prometheus and so on, right? So Let's see how this fares against. Let me just really quickly check my init Gradle. Okay, it's commented out all the stuff. Perfect. Now in my settings Gradle here, I use just the remote build cache. Okay, so just the one that I'm supposed to be accessing. I'm still connected. Okay, just making sure that everything is fine. Okay, so on my other machine, I also have this project, right? I have it cloned on both places. So I expect this when I run classes, for example, to generate some build cache entries and push them to my remote build cache, right? So if you wait a bit more, okay, cool. It scanned and so on. It probably stored it before because I already pushed to the remote build cache. Nice. I accept the terms and conditions. And okay, there's more stuff to work with here because there were more tasks, right? So if you see here, 61 tasks, 14 projects, 38 avoided tasks because it has a cache. Maybe it's using the local one, maybe it's using the remote one. In this case, it's using the remote one, as you might know. And then if you look at the task path here, let me just zoom out a bit. Yeah, everything is up to date, right? So it knows that, okay, everything is up to date. If I rerun it, rerun tasks. Okay. 4 minutes. So it says, I don't know if you saw it, but for a brief millisecond, it said they're updating to remote build cache, right? Uploading to remote build cache. Because it knows that, okay, I'm connected to this, and I said is push equals true, okay? By default, of course, on your machine, you will never push to the build cache. Your CI/CD pipeline will build things, put them in the cache. Your colleagues will come tomorrow morning, because you were coding at midnight or whatever, the pipeline passed. They clone that branch locally, or they clone the main branch. They run Gradle build, success. They didn't need to wait for anything because they didn't change anything, right? They just pulled the code. They wanted to build the project locally, so it does the same for them. But does it? Like, okay, so here, if we look at this build scan that I run on my machine, you might say, okay, it just ran on the machine. Sorry, timeline. Let's go fast. 61 tasks executed. Interesting. Okay, so because it pushed to the cache, right? So this, you would assume that it did something. Now, if I do a Gradle clean classes here on my other machine, like the one that's at CERN, it's, well, just to make sure, Gradle, yes, yeah, should be okay. Okay, and now still really fast because it says 18 from cache here. Interesting. Let's have a look. So now you can see a bunch of tasks that say, hey, actually compile Java for this particular project. Well, I don't need to do it myself anymore, right? Because I know it's somewhere out there in the cloud because I asked about it. The hash looks the same for my project. It gives you back the cache data and so on, and then you get the nice little bragging graph saying avoided 11 seconds and everything was built in 3 seconds or something, right? Imagine this on a way, way bigger project with a lot of submodules, right? And then at some point you might end up in the situation where you want to build it. Well, you don't build everything. You just build your changes, and then everything else comes from above. All right. Well, now the question you need to ask yourselves is what makes your developers more productive, okay? This applies a lot to us because it works with our current structure and so on. But maybe there's some things that we missed. Maybe there's some things that you guys think make more sense for your current use cases and so on. Also, the technical debt, maybe consider about it, put it on the roadmap and so on. And yeah, I will leave you with this. So there's a code over there that you can scan for the slides. There's also the actual code, like the build cache stuff. There's not a lot of it, but you can play around with it and understand how it works. And thank you. If you have more questions, put them on the Slido over there. Otherwise, there's also like all the social media profiles if you want to connect. Send me a mail, a pigeon, whatever. Thank you very much.